So arrays का basically सबको structure पता ही है कि arrays कुछ we will store the all our elements in the contiguous fashion और सब same data type के होने चाहिए. पर कुछ there are some problems we are facing with arrays. So the first one is that user can't change the size of array. यानी कि size एक बड़ा issue हो गया था. We can't change the size of array once user has declared it. Obviously there are dynamic arrays and we have figured out many solutions to that. But still, in the normal arrays, when we can, if we have defined the array size once, we can't change it afterwards. The second problem is that if you want to insert something in middle, so the operation is very costly. It is O of n. If I want to insert something here or if I want to insert something here, the average case complexity is O of n, right? Also, one second, someone wants to join. Also, the third issue which we are facing in an array, that our memory is fragmented. What fragmented means is कि there is some memory location, memory free here, some memory free here, some memory free in other memory blocks. So basically, the array wants to store all its element in a contiguous fashion. That means the array wants a complete block. If you are storing 100 elements in an array and all of are in data type, that means 4 bytes, so it counts up to 400 bytes. So if there is a memory location of, if there is a memory of 200 bytes here and 200 bytes here free, so we can't use this memory space because we want 400 bytes as in the contiguous manner as a complete block. So all these are the pretty limitations of array, we can say. So to solve these limitations, we came up, one second, my phone. So to solve all this limitation, we came up with something known as linked list. So the first issue it's gonna solve is कि we will not store all the elements in a contiguous manner. We are not required to store the elements in a contiguous manner. We can store them in a different memory locations. So first issue हमारा resolve हो गया. Second कि यूजर को साइज बताने की जरूरत नहीं है. हम उसका साइज कितना भी बढ़ा सकते हैं, कितना भी कम कर सकते हैं. And basically, if user has entered that I want a linked list of 4 size, if in future he has changed his mind and he want to add another element, the complexity of adding one more element is O of 1 only. Why we can't do this in our arrays? Like why, for example, here only, see, this is the array, right? So if there are 5 elements, and suppose the first memory location is 1000, the second is this. So कोई बोल सकता है कि why can't we store any element in 1024 memory location? है तो हमारे पास, we can access. Why can't we store any element here? So if anyone wants to answer this question. We know
arrays में free allocated होती है ना memory.
नहीं, there is a memory free here also. Like there must be some memory here. There are very less chances that जो ये वाले मेमोरी एकदम एंड में ही आए और हमें कोई और मेमोरी एक्सेस करनी पड़े. मेमोरी इज इन्फिनिट, ह्यूज. सो ये कोई 1024 मेमोरी लोकेशन होगी तो है ही. Why can't we store it there?
But how will you able to get that address location, or we have to store in that place only? Means how we can able to know that location?
to know that location is very simple. If I have an array size of 5 and I want to enter the sixth element, to know the location, it's simply if like S मान लो. This is the memory location, base location plus 5 into S. Now why we can't store it that way? 6 if we want to store this way. Because
Size is fixed.
the size is fixed. I'm saying size is fixed, but there is a memory location there now, and we can access this memory location very easily. If you want to access put an element on this fixed position, I can access this memory location. And once I access this memory location, I can enter anything I want to do. Why am I not using this? I can't use this because we don't know कि ये वाली जो memory location है ये हमारे लिए available है भी या नहीं. मेमोरी में कुछ ऐसी मेमोरी लोकेशंस होती हैं जो कि यूजर को एक्सेस करना अलाउड ही नहीं होता है, वो इंटरनल कंप्यूटेशंस के लिए यूज होती है. तो इफ वी एवर ट्राई टू यूज दिस मेमोरी लोकेशन, इट माइट बी अ केस कि हम रन टाइम एरर मिल जाए. सेकेंडली, मे बी एट दिस मेमोरी लोकेशन देयर इज समथिंग important already stored. It is not free. It is not guaranteed that this memory location will always be free. We don't know anything about this memory location except of this address, so we can't use it because it can be dangerous, right? There might be some private information, there might be any information that can't be altered, and we are directly accessing it, and we are directly updating it or removing it, deleting it, the value. So easily we can't use this in our arrays. But in linked list, to solve this problem, we have we don't allocate all the elements in a contiguous fashion. We just say that ये सब जरूरी नहीं है कि हम सबको एक मतलब हम सबको कॉन्टिन्यूसली स्टोर करें. अलग अलग मेमोरी लोकेशंस पर भी एलिमेंट्स हो सकते हैं. पर इससे क्या दिक्कत आएगी? हाउ विल वी कीप ट्रैक ऑफ द एड्रेस? If I want to keep track of this address, I have to store it in a separate place. For example, the address I'll store it here. Similarly this, similarly this, similarly this. So for storing the address only, I have to create an array, and it again creates the same trouble. If I want to add another list in another node in my linked list, and the array size is full, the problem again comes into picture. I have to the complexity of adding one more pointer element here would be O of n. So it is not it is not an ideal solution to do that. So ये वाला solution तो हट गया. So what we can do with this? Why don't we use a chain type of structure? What I mean by chain type of structure means that this
Hello, Didi.
Huh.
Sorry for the interruption, but I was having a doubt regarding that array. Suppose that means the array size is of 10, and we have allocated 5 locations. But after 5, the 6th, 7th, 8th, and 10th location is free. But can we add at the end? Can we able to add on the 6th position? Means we can insert at the 6th position. That
Right.
can be possible.
But after 10, the problem again comes now. It was this solution we can also do with arrays. Suppose the user entered 5 only, so just to avoid this problem, I can allocate a size of 10. But this is a temporary solution. There can be a case that user wants to enter the 11th element also. We want everything to be dynamic. We don't want us to have any limitation on the storage side nor on the computation side. We just want everything to be dynamic. So for this, what we try to solve, that why can't we have a chain type of structure? What do you mean by chain type of structure is that this element will store the address of this one, this element will store the address of this one, this element will store the address of this one, and this element will store the address of this one. So this problem will remove the problem, this solution will remove the problem of creating a separate array space for all the pointers. but implementation type wise it might be a little tough to implement, right? Because we want this particular storage to store two things. One is the data it has, right? For example, array will store a, so linked list must store a, right? That's the only point we want to store the value. And the second is to address. So we want to store two things. Is there any primitive data type we have that can store two type of address, like two type of data types?
Structure.
Structure, we can have a structure, but structure is not a primitive data type.
Map.
They are not primitive, they are derived one. So we have to create, like we have to use these data types to create this type of storage. So we can either use structure or we can use class. So in the class, suppose I am using class, the syntax is pretty same. Class, the name of the class is node in data, or it must be storing the address of the next node. So suppose it is next. What will be the value here? It is storing the address of my next node, right?
So node star next.
So that means that it is storing the address of a particular object that is of node type. So the address type would be node. Anyone has any confusion why we are using node here? So this is the basic structure of the class we can use if I want to store two types of things in my single storage. Now what this class objects will have: one, the data, and second, the address of the next node, right? Up to know the like how to create all this, there are two ways. First, we will declare the class. बिल्कुल ऐसे, this is the right thing. How to create the object? Now object creation is of two types. One is we can create it statically, and one is we create it dynamically. So this by static, what I mean is that just like the int a, we are creating a variable named a of int data type. Similarly, node n1, we are creating a variable node, we are creating an object variable node of data of class type node of like named n1. So n1 is basically the name of storage and the blueprint of something like this. One is data, other is address. This is the static. Static means कि out of the like once the scope is over, like once the block scope is over, we can't access this anymore. Similar in the int thing. Like if I have declared any int variable inside a group, I can't access a here. It will give an error because the scope or life of that variable is under these parentheses only. One is dynamic. So what basically is dynamic? Dynamic is what in dynamic bit does is we will create a node dynamically in the memory, and we will store its address somewhere in a variable. So this n1 is an address, it is a pointer. A new node is creating the node dynamically. What dynamically means that until and unless I am gonna delete it by using a delete operation, it will be in the memory forever until our program runs. It will not get deleted. Like if it will, we can access it anywhere. So we can use any type of any method to create a node. Either we can use the static method or we can use the dynamic method. Right? Is like someone having any doubt regarding this? Okay, just give me a minute. I have to reply. If you want to note something, you can note. Just give me a second. So, okay. So we know that how to create objects. Basically, how to create a node. In linked list, we will create these objects as node. We will use the term node for referring these objects. Suppose I'll create one node of node n1, and first we have to create a constructor as well to give the type, to give the data to our node. So do you know about constructors? Yeah, so this is the class node. This is the class node. It is the int data. It is node star next, and then we will create a node. This is a constructor. Constructor will have the same name as of class. It will receive an argument. What is the value you want to store? What it will do is, this means what basically this means, this is the data pointer that is referring to the object, to the current object on which we are operating. So what it will do is, it will assign this next to null. That means that the next pointer will point to null, and it will store the data as the data provided by the user. Okay, so once this constructor is done, we are good to create an object. So node star second. We'll first learn how to create it statically. So we will create an object node n1, and once we have created our own constructor, the default constructor will not be in use. So we have to provide a value here. Like while object creation, we have to provide some value here because our constructor is accepting an argument. So what I do, for example, I'll store 10. So the first node, as soon as I do this, there is a node that is created. It will store 10 here and it will store null here, right? The second one is node n2, 20, and once I do this, it will store 20 here and null here. Right? Now I want to connect these two. I want to store this element in this fashion. So for that, they need to be connected. By connected, what I mean is, instead of null here, I'll store the address of this one. So this is of n. This is n1 variable, and this is n2 variable, and this is n1 variable. How to know the address of n2 variable? What is the method? How can I access the like address of n2 variable? Do anyone know?
When we keep a track of the pointer using the head pointer of the address, we can keep the track.
No, we don't need to keep a track here. Basically, what we need is that we need to know what is the address of this, like where in the memory this n2 is created.
From n1.next, we can access n2.
But we have not stored anything in n1.next. N1.next is still null. Take an example of int. Int a. A is equals to 5. Somewhere in the memory, a is created with the value 5. I want to know the address of a. What I need to do? The address of a I can access using this, na?
And a ampersand operator.
Similar in the case of nodes as well. If I want to know the address of n2, I can use this one. It will give me the address of n2. So what I'll do is, n1.next is equals to n2. I will do this only, and instead of null, suppose this is created at 2000 memory location, instead of null it will be 2000. This thing is clear? If any of you has any doubt, you can like ask Abhi only.
Is it n2 only or n% n2? n1 dot next equals to
Right.
n2.
It is n%. Okay. Suppose you have created one more node n3 that will store 30. This is created in the memory. It will again store null, because in the constructor we have put the value null. It will again store null. And if I want to connect these two nodes, what I need to do is I need to update the address of my n2 node, because n2 will contain the address of its next pointer, and what we needs to store, it will store the address of my n3 node. That is n2 dot next is equals to star like ampersand of n3. Right? Okay, so
I have one doubt. When we use dot, when we use arrow symbol, like n1 arrow dot next that.
okay, so this dot is used when this thing is a like object. This is a variable. And arrow thing is used when on the left of this there is a pointer.
Oh, okay.
There is an address pointer, and this is a simple object similar to a variable. Okay, so basically हमको static node बनाना तो आ गया है. This is basically n1, n2 and n3. To create them, it is pretty simple. Node n1 10, node n2 20, node n3 30. No one has any doubt in why I used a single node. It is similar to int a, b, c. Similar thing.
Mom, like
Yeah.
why do you use this pointer? Like I usually use struct, so I'm not that familiar with classes.
Okay, so this pointer is basically the pointer. This is a generic pointer that will refer to the current object on which we are operating. Now, if I am doing this, like I am working on n1, so this pointer will be pointing to this n1. It will store the address of this n1. It is the pointer that will store the address of the current object on which we are working, basically. एक अपना एड्रेस जो भी ऑब्जेक्ट स्टोर करेगा वो दिस में करेगा ऐसे. Once all these nodes are created, I can just connect them. n1 dot next is equals to address of n2. n2 dot next is equals to address of n3. Now, the second option is that I will create the linked list dynamically. Okay. So what dynamically means is that I'll use the like dynamic memory allocation part. So it would be node star n1 is equals to new node and the value of our element we want to store. 10. This is the basic syntax. If we are trying to allocate, if we are trying to use the dynamic memory allocation, we have to use this. Okay, this n1 will store the address of the new node we have created. Somewhere in the memory, this thing has happened similar to the static. Suppose it has stored at 2000 memory location. So n1 will be pointing to this 2000. So n1 will store 2000 memory location. Now, if I want to access the data of this node, I will just use n1.data. It will give me the data. If I want to use the next of this node, this will I'll get it by this. Okay. Now, suppose we have created one more node node star n2 is equals to new node 20. Similarly here also this has happened. Suppose it is of 1000. So n2 will store this one. Now I want to again connect these nodes. What I need to do? I basically need to remove this null with its address. Right? Okay. So I need to remove this null with its address. Ab I can access the address using this. What I need to store in here? What would be the here?
Just n2.
N2.
Correct, because n2 already has the address of this node. Correct. So similarly, if there is any node n3, it would be new node 30 n2 dot next is equals to n3, and all these are connected. Abhi we know how to store the elements and how to connect them. Now we know like how to store 10, 20, 30 in the memory. User can anytime say that I want to also store 40, and there will be no memory constraint. We just have to create this new node and we have to connect it with the previous pointer. But how will we keep the track of our first node, like the address of our first node? उससे बात के तो we will already know. Like if I get to know the address of this node, I can move to this. To keep the things generic, we always refer this first node as the head of linked list. Head will always contain the n1 pointer or any pointer user has used, any variable user has used. So basically, if we know the head of the linked list, we can do anything. We can either insert it, delete it, put element, remove element, reverse it, like any operation. We are only given the head and we can do any operation you will use. Similar like just like arrays. In array also we are only given ARR, the base address, and we will do anything with that. So here we can use head, the first node address, and we can do anything we want to do. Now the point is that how can we print the linked list? We know how to store them, but how to access them basically? We know that there is a pointer named head, and suppose we have a function void print, and it will obviously receive a single argument head, as I just said that we only need head to do any operation, and now we want to do something to print the list. What's something I need to do? Someone has any idea? You can tell me.
You need to traverse the linked list.
Ma'am, we can use a for loop for ptr is equals to head till ptr is not equals to null. ptr is equals to ptr of next.
We can do that.
Yeah.
We have to use a loop for sure. Loop तो लगेगा ही लगेगा. We have to print all the elements. We are printing all the elements. Basically, we are doing similar thing again and again, printing. So for loop to lagega hi. Either we can use a for loop or we can use a while loop. For loop, as Alok has already discussed, we can make a pointer, or we can basically increment the loop. Try doing that with a while loop. So the first thing is we will not alter our head by any chance. Our head will remain intact. If we change our head, we will lose the track of our linked list. So head, we have to store head first in a separate variable, and then we have to do all the computations using this variable. Okay. Now my idea is, first एक second. This is the basic structure. It is 900 the address, what head contains. ठीक है, we have the value of head. So now we will once we have the complete structure, we want to traverse it. We have the value of head, we have already stored in our temp. So first we will print this element, we will move to the next element, print this element, move to the next element, and we know when to stop when we want to move to next element and the current element we are on, like this is the null na. So when we are at null, when our temp will become null, we will stop. We can't compute anything. We can't access the null memory. It is a rule. We can't we can't access the null memory. Just like this. So basically जब तक हम null नहीं पहुंच जाते, temp not equal to null, we'll try to access temp. As temp is not equal to null, we can, instead of cout, I can just write, नहीं cout लिख देते हैं. Instead of cout, I can just write temp का data, and then we will move temp to temp का next and this. So basically what I am doing is I am first at this memory location. I check that if my temp is null, no. I'll just print this 10 and I'll move my temp to the next memory location. Next means whatever the temp is accessing. I just got a message from some student. Okay. So yeah. Now our temp is at this memory location. We will just print this 20 and my temp will again become 3000. 3000 means that it is pointing to this memory location. At this we will print 30 and my temp will become null. It means that it will point to this null, and once it is null, we are end our loop. Is it clear? Now we are printing the linked list. We have to just be aware that we are not accessing any null memory, or how we are traversing, and if we are not changing our head. The first rule is that don't change your head ever, and the second is that while accessing anything, just keep a track that if you are accessing a null value or not. If you are accessing a null value, just stop, just change your algorithm or whatever code you have written. Okay, so traversal we have already done. Now comes to the first problem. We want to insert anything. There can be three ways to insert. First, we want to insert in the beginning. Second, we want to insert in the last. That is also called as a tail. And third, in the middle, at any position. Position is already given to us. So in the beginning, if I want to insert anything in the beginning, we are already given this is the head. I want to insert 30. This is 1, 2, 3, 4, and this is null. I want to insert 30 in the beginning. First step is, if I want to insert 30, first I have to create my node. Right? To create a node, I'll create node star n is equals to new node 30. Okay. Once I have created this node, I have to, if I want to insert it in the beginning, definitely my head is going to change. Right? So what I need to do is, my node is created 30 and it will now store null, but what I want is that it will store the address of this value, and now my head will become this. That way I'm inserting an element in the beginning, right? Anyone has any doubt in this approach? Now it is a pretty simple thing. I just want to do this and it will become, but I need to change my head, right? If I won't change my head, I will always compute my linked list from here only. We don't know that there is a memory location that is pointing to my this address. We will be accessing our linked list from this point only, and it will be of no use if I am like adding something. I have to keep track of my head while inserting or deleting any node from the linked list. If my head is gonna change, I will change it. Second thing is, if I want to insert something in the last. If I want to insert something in a last, is there any way of inserting something in the last within complexity of O1? The complexity of inserting in the beginning is O1, right? We are not traversing any loop. We are just creating a node and we are just like rearranging the address only. But if we want to insert anything in the last, is there any way of doing this by O1 complexity?
Using
We can use tail pointer.
Yeah, we can use a tail pointer. There is, like I just realized, there is an error. Is there any error in this approach? Have you tried it on all the test cases? There might be or might not be. There is no error. I was just testing you. I just want you to think of the case when there is an empty linked list. So if the linked list is empty, head will be null. So what we are doing is we are storing n dot next is equals to head, that is null, and we are storing the value of head in, like we are storing the value of n in head. So it will run fine. There is no error. In moving on to this question, there are two ways to do this, either of O(n) or O of 1. In the case of O1, we need to keep track of our tail pointer, and this one. Then only we can create a pointer, and then we can move update our tail pointer, and the complexity becomes O of 1 again. But in the single linked list, if there are no this thing, or like if the linked list is not doubly, we will, like, there are very less chances that we are given the tail of linked list. We don't store the tail of linked list because it is too much computation to update the tail and to update the head. It just creates the confusion. What we prefer is we just traverse through the linked list to the end. We get to know this address, and once we know this address, we will create a node and we will put that this, like for example, we know that this address is n, this address is L, like last. So we will do L dot next is equals to our newly created n, and n dot next is equals to null. Pretty simple, but the complexity is O of n. How to reach to this address? Using a for loop, simply, just like traversal. In the traversal, we are stopping our while loop when we have reached null. But in this, when we want to access this memory location, we will stop our while loop. If example we are using temp, we will stop it when temp dot next is not equal to null. When temp dot next is equals to null, it means that we have reached the last one. But now we are generically using temp dot next. But suppose temp is null, it means that the node, that our linked list contains no node. The linked list is currently empty. What it means is that we can't use this. If we will use this, it will throw an error. For that, we will just check that if my temp, yani if my head or temp, we will use temp because we have stored the address of head in somewhere else. So if my temp is equals to null, what I need to do is I'll just create the node and I'll just return, like I'll just update the head, and this is all. Because that would be the only node. I just need to do this. Right? If someone has any problem in this? Okay. Achha, what is the next problem we can do is we want to insert in at certain position. Seems like difficult but very easy. Why it is not moving up? If I want to insert at any ith position, what I need to do is something like this. Suppose I is 2. I need to store 100 at second position. This is the first position. This is the second position. I need to, like at second position means that it will do something like this. Okay. So in this case also, we will traverse until I minus 1. We will keep a track of count. This is the 0th and this is the I minus 1. We'll keep the track of count while our count is less than n. And the current node I am on is not empty. For example, I want to insert something at 1, 2, 3, 4, 5, and I want to insert something at 7th position. So we will move forward, and some point at temp will become null, and we'll try to move temp is equals to temp dot next. That will raise an error. So in this case, we have to just keep track of first is to count should be less than n minus 1. We don't have to run, like we have to, this is I minus 1, this is I place, and this is I minus 1 place. We want the address of this one, because the address of 3 we can already on, like we can get from 2, right? The address of 3 we can get from 2. Once we get the address of 2, what we need to do is we need to, like I am accessing it as 2 only, it is just for reference. We need to do is 2 dot next is equals to 100, and 100, we will first do 100 dot next is equals to 2 dot next. I did this first because 2 dot next, like we will lose the third node address if we will do this step first. We are overwriting the 2 dot next. Are you getting what I'm saying?
Yes, ma'am.
So first we will store the address of 3 into whatever node we want to store in the hundreds node, and then we will update the 2 dot next. We will update our 2 dot next, like this node's next into this, the newly node we have created. It is pretty similar. We have to reach to this node. For this, we'll keep a count variable, and we'll check that like whatever node I am on, it is not equal to null. If we are at null, that means that we are asked to insert something at the last, at the tail, right? So insertion, all 3 insertions are done. Now what we can do is We can search in a linked list. Like all the operations we can do in an array, we want to do all those operations here as well. What we need to do if we want to search a linked list? Suppose we are given a linked list node star head. Int will return at what position we found the element. Search is the name of function. It will take two arguments, node star head and int p. P means that what element we need to search. We will create a temp element again. It will store the address of head, while temp is not equal to null. Initially we will keep our position 0. Suppose if we found the element on the 0th position itself. If temp dot value or data, whatever you can use, we will use data. If temp dot data is equals to p, that means we found the element, we'll just return p position basically. Else अगर ऐसा नहीं होता है, it means that we need to increase our position and we need to move our temp as well. Temp is equals to temp dot next. And if we don't find the element, if we don't find the p in the entire linked list, we will just return -1. Is it clear? Okay, search is done. And the next step is we want to delete any element from the linked list. All the three operations, insert, delete and search. These are the three operations a data structure must support. We have checked for insertion, doing fine. We have checked for searching, doing fine. The complexity of O of n, we can't do anything about it as of now. Now we want to delete an element. So delete is this one. There are still three cases: delete at beginning, delete at end and position. किसी एक position. Delete at beginning. While we have, as we have discussed earlier also, that when we are creating a node dynamically, we have to very consciously delete it after we are done with its usage. So now I have created a node n1 and we want to delete. This is a simple node, nothing a part of linked list. I have created a node n1, we want to delete it. To delete it, I just need to use delete n1. Okay. So while we want to delete anything at the beginning of my linked list, what I'll do is, this is the linked list. This is the head. The basic thing what we need to do is, we need to delete this node and we want to update this head to here. Nothing else, right? So for doing that, we will first store our head into some other variable. This is not creating a different variable. This is just creating a different pointer variable to store that memory location. So the memory location, it will say, like, basically this is the memory location. So head is also pointing to this memory location and temp is now also pointing to this memory location. Don't get confused that we have created a different variable. So how are we deleting that? So हमने इस temp, we have stored the head into a temp variable. And now what I need to do is, head is equals to head ka next, delete temp and return. Please forgive my writing. Return head. If you want to insert anything in the beginning, like if you want to delete anything in the beginning, obviously our head will change. So the function must accept like node as a return type. The function must have node as a return type. If you want to delete something from the end, The complexity will be O of n, because we have to first traverse it. We have to first traverse to this node, and then we have, like, we don't want to traverse to this node. Basically we want to traverse to this one, the second last node. So basically if I am using temp, so temp dot next dot temp dot next means this node. So temp dot, we have to stop at this. So temp, like if I am at this position, temp dot next. Yeah. So first we will check. There are too many cases for deleting at the end. The first case is if our head is null, the function must accept node as an argument, like address of node as an argument. I have already discussed why. Because there might be a case that our head is changing. If our head is null, we will return null. We have nothing to delete, we will just return null. If my head dot next is null, that means that the node contains only a single node, like the linked list contains only a single node. Then also we were basically deleting that node and returning null. So it is delete head and return null. Itna clear hai? Now the third thing is we want to basically traverse to a point. Suppose ये हमारी linked list है ना. So we want to traverse to this node because we want to delete this and we want to delete this. देखो दो चीजें हैं. If I am gonna delete this, I have to update the address of this one as well. इसका जो next है वो ये store कर रहा है, पर मुझे अब अगर मैंने इसको delete कर दिया तो I have to make it null, right? So while temp.next is not equal to null, हम अगर ये चीज़ अगर हम ये लूप लगाते तो देयर माइट बी अ केस कि टेम्प तो नल नहीं हो जाए या टेम्प का नेक्स्ट ये ऑलरेडी नल हो. तो वो हमने ऑलरेडी यहाँ पर दोनों में कवर कर लिया है कि ऐसा नहीं होगा. एक पॉइंट तो आएगा ही जब यहाँ पे होगा, तब तक हम टेम्प को अपडेट करते रहेंगे. टेम्प इज इक्वल्स टू टेम्प डॉट नेक्स्ट. बेसिकली जब हम इस लूप से बाहर निकलेंगे हम इस पोजीशन पर हैं. नाउ व्हाट वी नीड टू डू इज, हमें अब इसका एड्रेस चाहिए. तो हम इसको डी ले लेते हैं क्योंकि ये डिलीट होने वाली है. सो डिलीट इज डी इज इक्वल टू टेम्प का नेक्स्ट. अब सबसे पहले तो मुझे इस डी को डिलीट करना पड़ेगा. वेरी इंपॉर्टेंट स्टेप. सेकेंडली मुझे अपने टेम्प के नेक्स्ट को नल करना होगा और मुझे रिटर्न करना होगा हेड. नो चेंज इन द हेड बट स्टिल आई नीड टू रिटर्न बिकॉज फंक्शन एक्सेप्ट कर रहा है. व्हाट इज द कॉम्प्लेक्सिटी ऑफ दिस? O of n. बेसिकली आई कैन से दैट थीटा ऑफ n ऑल्सो, बिकॉज हम पूरा लास्ट तक ट्रेवल करेंगे. एनीबडी हैव एनी डाउट? ओके, सो
Please,
हमने
ma'am, explain once again, please.
Okay. So, is there any particular step you want to
In
take?
this while portion.
Okay. So while में हमें basically अगर हम जैसे linked list में से suppose 1, 2, 3, 4, 5. I want to delete this 5. So what अगर मैं इस 4 को थोड़ा सा खोलूंगी तो what it is containing 4 and address of 5, right? I can delete this 5 बड़े आराम से. I will just move to the last of linked list और जब मैं लास्ट पे होंगी तो मुझे इसका एड्रेस मिल जाएगा. I will just do delete 5, right? पर अगर मैंने ऐसा कर दिया तो this memory location, what would happen to this? It will be containing a false information. I have to do this to null also. और single linked list में we can't travel to back to do that. So I have to stop here only 4, because once I am at 4 I can access 5, but once I am at 5 I can't access 4 again. So to stop at this what I need to do is कि मुझे कहाँ रुकना है? टेम्प मान लो मेरा करंट वेरिएबल है, टेम्प का नेक्स्ट मीन्स यहाँ पे, और इसका नेक्स्ट जब तक वो नल नहीं हो। वंस दिस इज नल इसका मतलब हम यहाँ पर आ चुके हैं और यहाँ पे हमें रुकना है, ठीक है। अगर हम यहाँ पर रुक गए हैं तो ये वाला पोर्शन समझ आया कि हमने टेम्प का नेक्स्ट क्यों किया है।
Yes.
अब हम यहाँ पर रुक गए हैं, तो अब हम क्या करेंगे, इसके जो ये वाली मेमोरी लोकेशन है इसको कहीं और स्टोर करके उसको डिलीट करेंगे, जैसा कि हमने यहाँ पर किया है, उसको डिलीट करा है। फिर उसके बाद जो हमारी पर्टिकुलर जहां हम रुके थे उसके नेक्स्ट को हमने नल किया है और हमने रिटर्न कर दिया है हेड। ओके, ऑल दी ऑपरेशंस आर डन बेसिकली। अब हम क्या करेंगे, लिंक लिस्ट में जो बेसिक ऑपरेशंस थे लिंक लिस्ट के, इंसर्शन, डिलीट और सर्चिंग, वो तीनों हो चुके हैं। We are done with this. If any of you have any doubt regarding all these operations, मेरे को बता दो, we can discuss that. हाँ,
But means if we are deleting that, the footnote is deleted, and suppose we can't able to do that, means temp next is equal to none for the fourth position. Okay, so what will be the output if we print that portion? It will print the data.
अच्छा, if we don't do this part, like अगर हम skip करते हैं इस part को, तो क्या होगा कि जब हम अपने लिंक लिस्ट को ट्रैवर्स कर रहे होंगे या सर्च करोगे, कोई भी ऑपरेशन परफॉर्म कर रहे होंगे, तो हम क्या बोलेंगे कि अच्छा अभी तो लिंक लिस्ट नल नहीं हुई है, तो इसका मतलब हम 2000 पे जा सकते हैं। तो हम जब जैसे 2000 पहुंचेंगे वहां हमें कुछ भी नहीं मिलेगा, वी डोंट नो व्हाट डेटा इज स्टोर्ड देयर। अब हम उस मेमोरी लोकेशन को एक्सेस करेंगे भी तो पता भी नहीं है कि वहां पे क्या डेटा है। सिमिलर एरे के केस में हम एक मेमोरी लोकेशन को एक्सेस कर सकते हैं पर हम नहीं जानते वहां पे क्या है, तो उसको एक्सेस करना बेसिकली डेंजरस है।
गार्बेज वैल्यू देगा,
गार्बेज वैल्यू हो सकते हैं या कंपाइलर ने अपना वैल्यू रख रखा होता है, या फिर कोई इन्फॉर्मेशन हमने स्टोर की हो सकती है। सपोज हमारे यहाँ पर हमने कोई बीच में नोड इंसर्ट की थी उसके डिलीशन के बाद, और उसको हमने अब 2000 मेमोरी लोकेशन असाइन किया है, तो अब यहाँ पे 2000 है, तो अब बेसिकली हम 2000 बनाएंगे तो हम यहाँ पे जा रहे हैं, और फिर हम अब तो हमें नल मिलने से रहा क्योंकि हम सपोज 1 था 2 था, एक सेकेंड, 1 2 3, यहाँ पे 4, यहाँ पे 5, यहाँ पे। अब हमने 4 के बाद ये 5 वाले नोट हटा दी थी, लेकिन हमारे जो 4 वाली नोड है वो अभी भी 2000 ही रखे हुई है। अब सपोज डिलीशन के बाद हमने कोई नोड इंसर्ट की 60, हमने वो इंसर्ट की इस पोजीशन पे। इंसर्शन हमें पता है कि किसी पोजीशन पे इंसर्ट कैसे करते हैं। कंपाइलर को देखा कि भाई 60 नोड हमें इंसर्ट करनी है और 2000 मेमोरी लोकेशन अब खाली है, मैं उसको एक्सेस कर सकता हूँ। कंपाइलर ने क्या किया कि 2000 मेमोरी लोकेशन पर हमारी 60 नोड बना दी। अब यहाँ पे ये 3 का एड्रेस स्टोर करेगी। सपोज ये है हमारा 100, ये हमारा 200, ये हमारा 300, ये हमारा 400। तो हम 60 में क्या कर देंगे कि 60 है 2000 मेमोरी लोकेशन पर, और ये अब ऑब्वियसली 3 का एड्रेस स्टोर करेगी, तो यहाँ पे हम 300 स्टोर कर रहे हैं, और ये हमारे 2000 मेमोरी लोकेशन। अब हमें खाली दिख रही है, अब वो यूज में नहीं है। तो अब मान लो हम ट्रैवर्सल करने की कोशिश कर रहे हैं, 1 से गए 2 पर, 2 से गए 3 पर, 3 से गए 4 पर, 4 से 5 पर, लाइक 3 से गए 4, 2 से गए 60 पर, 60 से गए 3 पर, 3 से 4 पर। 4 के बाद हमने देखा कि नल नहीं है, 4 के बाद भी हमारे पास 2000 है, तो हम क्या करेंगे, हम 2000 पे जंप कर जाएंगे। हमें क्या पता, हम जैसे यहाँ पे 2000 पे जंप किए तो ये बेसिकली एक लूप बन गया, नेवर एंडिंग, हमारा फॉर लूप कभी खत्म नहीं होगा। तो बेसिकली इट इज डेंजरस टू यूज दिस मेमोरी लोकेशन जिसका हमें अता पता ही नहीं। अभी समझ आया क्यों नहीं यूज कर सकते हैं?
यस।
तो लिंक लिस्ट से तो हमारा ऑलमोस्ट हो गया है सब। अब हमारी बारी आती है डबली लिंक लिस्ट की, और वो हम करेंगे कल, क्योंकि मेरे में नहीं है बिल्कुल भी एनर्जी।
मैम इसमें आप कल एक ऑपरेशन तो बता देना जो हमेशा इंटरव्यू में पूछते हैं, हाउ टू फाइंड डिटेक्ट लिंक लिस्ट साइकिल and
How to
remove
find
that
a loop in linked list.
and how to remove that loop in the
तो क्या क्या करना है?
उसको भी आप कल एक्सप्लेन कर दें, क्योंकि वही बेसिक क्वेश्चन पूछते हैं वो लोग।
हाँ, अभी हम डम्बली लिंक लिस्ट कंप्लीट करेंगे, उसके इंसर्शन, डिलीशन और इन सब की कॉम्प्लेक्सिटी देखेंगे। मतलब हमें बेसिकली काम करना आना चाहिए लिंक लिस्ट के ऊपर, मेन पॉइंट ये है। क्योंकि लोगों को अगर इम्प्लीमेंटेशन भी, मतलब अगर एल्गोरिदम भी आता है तो लिंक लिस्ट के ऊपर काम करना नहीं आता है। वो नल मेमोरी एक्सेस कर रहे होते हैं या हेड को ही चेंज करते हैं, उनको समझ नहीं आता कि उनके कोड में एरर क्यों आ रहा है। उसके बाद हमें काफ़ी प्रॉब्लम सॉल्व करने हैं। सबसे पहले तो प्रॉब्लम जो मुझे याद आ रहा है कि हमारे पास कोई सॉर्टेड लिंक लिस्ट होती है और हमें उसके अंदर कोई एलिमेंट इंसर्ट करना होता है, तो हमें वो एलिमेंट इस तरह इंसर्ट करना होता है कि वो लिंक लिस्ट सॉर्टेड रहे। एक ये प्रॉब्लम अच्छा है। एक ये होता है कि हमें लिंक लिस्ट का मिड एलिमेंट निकालना होता है, तो उसके भी काफ़ी वेज हैं, पर हम अपना ऑप्टिमल तरीका समझेंगे कैसे निकालते हैं। एक ये काफ़ी पूछा जाता है इंटरव्यू में कि हमें लिंक लिस्ट की nth नोड एक्सेस करनी है बट फ्रॉम द एंड। सो इसके भी दो तरीके हैं, एक नाइव सॉल्यूशन, एक एफिशिएंट। तो वो भी हम सीखेंगे कि एफिशिएंट सॉल्यूशन क्या है इसका। मतलब बेसिकली एक लॉजिकल ट्रिकी टाइप का सॉल्यूशन है, मतलब जो ट्रिक होती है। और भी एक वो जैसे अभी इन्होंने बताया है कि हमें लूप बताना है लिंक लिस्ट के अंदर, कि लिंक लिस्ट में हम कैसे लूप, बहुत ही क्या बोलते हैं, इम्पॉर्टेंट और स्टैंडर्ड क्वेश्चन होता है। उसको हम शायद हेयर एंड टॉर्टोइस एल्गोरिदम भी बोलते हैं। वो सीधा ही पूछ लेते हैं कि तुम्हें पता है हेयर एंड टॉर्टोइस एल्गोरिदम क्या होती है। वो लिंक लिस्ट में नहीं, बाकी इस तरह के डेटा स्ट्रक्चर्स में भी यूज हो जाती है कई बार, तो उसके नाम से भी डायरेक्टली पूछ लेते हैं कई बार हमसे। और कौन से प्रॉब्लम आ जाते हैं, एक प्रॉब्लम होता है जिसमें कि इस तरह का कुछ होता है, जिसमें कि हमारा एक लिंक लिस्ट ऐसे बनी हुई है, एक लिंक लिस्ट कहीं और से आ रही है इस तरह, तो दो इंटरसेक्शन बताना होता है।
मतलब add two numbers in the link list. I was rejected because of this question. Amazon. Add two
कौन सा वाला?
numbers. Add दो numbers को add कैसे करते हैं?
हाँ, वो क्वेश्चन भी काफी इंटरेस्टिंग होता है। इस तरह इसके भी दो वेरिएशंस हैं, ठीक है। या तो हमें इस तरह ऐड करना होता है 127 878 को, या फिर हमें उल्टा 8 को 9 कर देता है, या फिर हमको ऐसे करना होता है 721 और 978 इनको ऐड करना होता है। तो वो पहले समझना होता है क्वेश्चन में हमको पूछा क्या जा रहा है, वरना हमको पहले रिवर्स करना पड़ेगा, उसके बाद एडिशन करना पड़ेगा। और एक सबसे इम्पोर्टेंट क्वेश्चन होता है जिसमें हमें लिंक लिस्ट को क्लोन करना होता है, जिसमें कि एक रैंडम पॉइंटर भी गिवन होता है। दैट मीन्स एक ये है, एक नेक्स्ट होगा, 3 होगा, 4 होगा, 5 होगा। अब एक ना, जैसे क्लास का स्ट्रक्चर क्या था हमारा, इंट डेटा नोड स्टार नेक्स्ट और नोड स्टार रैंडम। तो यहाँ पे एक मतलब पहले तो नेक्स्ट होता है, पर यहाँ पे एक रैंडम भी होगा जो कि किसी भी रैंडम पॉइंट जगह को पॉइंट कर रहा होगा ऐसा। तो हमें इसी लिंक लिस्ट की एग्जैक्ट कॉपी बनानी है, जिसमें कि हमें नेक्स्ट को भी पॉइंट करवाना है, रैंडम को भी। तो ये सुनने में आसान लगता है, बट इम्प्लीमेंटेशन इसकी नॉर्मल तरीके से नहीं कर सकते, क्योंकि अगर हम वन का क्लोन बनाएंगे तो या तो हम रैंडम के साथ चलेंगे या फिर हम नेक्स्ट के साथ चलेंगे। और मान लो अगर हम नेक्स्ट के साथ चल रहे हैं तो हो सकता है कि हम रैंडम वाला कोई छूट जाए, इस तरह का बहुत इशू होता है। तो इसके दो अप्रोचेस होता है, बहुत ही इंटरेस्टिंग सॉल्यूशन होता है। और लिंक लिस्ट का एक सबसे स्टैंडर्ड क्वेश्चन होता है कि हमको कैश इम्प्लीमेंट करना होता है अपनी मेमोरी के अंदर। उसके भी दो तरीके होते हैं, तो हम एरे से कर रहे होते हैं, हम लिंक लिस्ट से कर रहे होते हैं। तो हम लिंक लिस्ट से करेंगे क्योंकि हम एरे कर चुके हैं। और हाँ, लिंक लिस्ट में हमको ऐसा होता है कि हमें 2 सॉर्टेड लिंक लिस्ट दी होती है, हमें उनको मर्ज करना होता है। ऐसे बहुत सारे प्रॉब्लम्स हम करेंगे, मतलब धीरे शुरू में तो हम पूरा समझेंगे, बाद में केवल हम अप्रोच समझा करेंगे, नहीं तो फिर हमें बहुत सारा टाइम लग जाएगा। तो शुरू में हम पूरा सॉल्यूशंस करेंगे, फिर बाद में मैं तुम्हें अप्रोच बता दिया करूंगी इस सॉल्यूशन को हम किस तरह हम मूव करेंगे। लिंक लिस्ट के बेसिकली सारे प्रॉब्लम्स जो है ना, वो एक बार ट्रिक समझ आनी चाहिए, उसके बाद तुम्हें लिंक लिस्ट को इम्प्लीमेंट करना ही बड़ा टास्क है। क्योंकि उनके जो लिंक लिस्ट के जितने भी प्रॉब्लम्स होते हैं वो एल्गोरिदम्स डिजाइन करने वाले नहीं होते कि उसमें सोचना है ज्यादा कि तुम्हें एल्गोरिदम क्या डिजाइन करनी है। उसके प्रॉब्लम्स होते हैं कि तुम्हें इम्प्लीमेंट करने आनी चाहिए, उनके तुम्हें पॉइंटर संभालने आने चाहिए। तो इसलिए आज मैंने पूरी क्लास इम्प्लीमेंटेशन के ऊपर ही की है कि तुम्हें कौन से पॉइंटर को किस तरह एक्सेस करना है, क्या करना है, कैसे ट्रेवर्स करना है, सर्च करना है, कहाँ से किस पॉइंटर को हिलाना डुलाना है, सब तुम्हें एक बार क्लियर हो जाए। उसके बाद हम चाहेंगे तो बहुत आसान हो जाएगा। बहुत सारे क्वेश्चन होते हैं इसके, पैलिंड्रोम, लिंक लिस्ट, पता नहीं और कौन से हैं, ऐसे कर करके। अगर अब तुम्हें बाकी कोई डाउट है तो पूछ लो।
मैम वो कल वाले क्वेश्चन में जो था एक मैक्सिमम सब एरे वाला, जिसमें हम सम निकाल रहे थे, उसमें अगर हम सम तो निकाल पा रहे थे, अगर उसके एलिमेंट्स डिस्प्ले करवाने हैं कि कौन कौन एलिमेंट से हमारा वो सम आया है, तो उसकी अप्रोच एक बार समझा दीजिए।
उसकी अप्रोच कैडेंस एल्गोरिथम से तो कर सकते हैं शायद हम, कैडेंस एल्गोरिथम से भी, क्योंकि कैडेंस एल्गोरिथम में हम बेसिकली क्या कर रहे हैं, हम एक करंट वेक्टर स्टोर करके रख सकते हैं कि इस पॉइंट पे हमारा क्या करंट वेक्टर है जो बना हुआ है। अगर हम उस एलिमेंट को ऐड कर रहे हैं तो हम उस वेक्टर को, मतलब उस वेक्टर के अंदर वो एलिमेंट पुश कर देंगे, और अगर हम उस एलिमेंट को ऐड नहीं कर रहे हैं, मतलब अगर हम उस एलिमेंट को ही ऐड कर रहे हैं, पुराना वाला वेक्टर डिस्कार्ड कर रहे हैं, तो हम उस वेक्टर को क्लियर करेंगे और उसमें सिर्फ अपना एलिमेंट पुश कर देंगे। समझ लो, मतलब हर पॉइंट पे करंट वेक्टर बनाए रखेंगे, और जिस तरह से हम प्रॉफिट को तभी, मतलब हम अपने सम को तभी मैक्स मतलब चेंज कर, जैसे मैं ऐसा कोई हम बना रहे थे एरे, और उसके अंदर हम कैडेंस लगा रहे थे, हम एक पर्टिकुलर एलिमेंट को पे चेक कर रहे थे कि हमें इसको लेना है, हमें इसको पुराने वाले के साथ ऐड करना है, या हम इसको सेपरेटली लेना है, राइट। तो हम सपोज एक वेक्टर बना लेंगे v, जैसे हम इस एलिमेंट के ऊपर है ना, तो हमने क्या करा कि अगर हमें ये एलिमेंट लेना हुआ है ना, जैसे कि हम वहां पे सीधा कर रहे थे ना कि मैक्सिमम ऑफ दिस एंड दिस, हमें उस टाइम वो नहीं करना होगा, इसमें हमको प्रॉपर इफ कंडीशंस लगाने होंगे कि इफ हम उस एलिमेंट को ऐड कर रहे हैं वो ग्रेटर है हमारे ARR से, सपोज करंट जो मतलब पुराना सम पीछे का P आया हुआ है, तो P प्लस ARR बड़ा है ARR से, तो हम इस एलिमेंट को ऐड करेंगे। तो बेसिकली हम v डॉट पुश बैक अपना करंट एलिमेंट ARR एल्स हम क्या कर रहे हैं, और जो हम p को अपडेट कर रहे हैं p प्लस ARR राइट, जो हमारा अभी बना हुआ है। एल्स हम क्या करेंगे, v को क्लियर करेंगे, हमें पूरा वेक्टर खाली चाहिए और हमें v के अंदर केवल डालना है ARR। हम क्योंकि ये स्टेप दोनों में हो रहा है तो हम इसको बाहर भी लिख सकते हैं, v डॉट पुशबैक और v डॉट पुशबैक को, और p इज इक्वल्स टू ARR। अब हम यहाँ पे नीचे चेक करेंगे कि अगर जो हमारा अभी तक का मैक्सिमम सम है वो छोटा है हमारे p से, यानी p अब एक्चुअली बड़ा हो चुका है ना, जो हम करंट जिस पर है, तो हम p को क्या कर देंगे सम के बराबर, और हम v जो हमारा अभी तक का मैक्सिमम v है, इसको vm मान लेते हैं, उसको कर देंगे v के बराबर। ऐसा कुछ, या तो हमें पूरा ही स्टोर करना पड़ेगा v को लूप लगा के, या फिर डायरेक्ट इस तरह भी कर सकते हो, तो देख लेंगे। मतलब मेरे को आइडिया नहीं है कि ऐसे कर सकते हैं कि नहीं फिर नहीं कर सकते, हमको डायरेक्ट उसको वापस से vm को बनाना पड़ेगा v की हेल्प से। तो बेसिकली हम हर पॉइंट पे v को कीप ट्रैक रखते हैं, ऐसा।
ओके।
और कोई डाउट?